Hello everyone, can you hear me? Is my voice all audible and you can see my screen?
জি শোনা যাচ্ছে।
Alright. Welcome guys, welcome to another session of Statistics for Machine Learning, AI and Data Science. And this is the day 6 of this community session. I'm Janisama Rosa. I'm currently studying in Breck University and this is my third year. This is the last day of this session. So without any further ado, let's get started. In today's session, we are going to talk about hypothesis testing, different kind of tests, then confidence interval, and some basics fundamental of hypothesis testing. So, firstly, we will cover the confidence interval. Then, then we will see fundamentals of hypothesis. Then, all right. In the fundamentals of hypothesis testing, we will see p-value, significance level, then two tests, one tail test, two tail test, and so on. All right. So let's start. Suppose this is your this is your population. This is the this is a class of student. This is the classroom of student in your college or school or university, and you want to find the average height. So for that, the classroom is your population. I think we should consider something big as population. Let's say the college is your population, and you want to find some samples to find the average height of the students of that college. So for that, you pick up some value from different classes, and let's say these are your sample. So one thing you will be seeing that every time you will have different value from different sample. I mean, suppose we are denoting this as classroom 1 or sample 1, this as sample 2, this as sample 3. So each time you find the average value, you will find some different value for height. Sometimes you will find the average height is, let's say, 5 feet 7 inch. Sometimes you will find it as 6 feet. Sometimes you will find it as 6.3 inch, and so on. So each time you will have different values for different samples. So surely there is some error, right? So there will always be error in sampling. So what does the confidence interval do? So the confidence interval is an interval which is obtained from the observed data. In this case, the samples are the observed data, right? That holds the actual value of unknown parameter. And what is the parameter? The parameter is height. We are testing the we are testing it for the height, right? So by confidence interval, we will see how accurate the estimate is likely to be. So, what is the confidence interval? All right. So, the confidence interval is that interval which is obtained from the observed data. that holds the accurate value, right? And by the confidence interval, what we will get how accurate the estimate is likely to be. Suppose in this case, since we had different values for different sample, we can say that this is our confidence interval. Suppose this is 95%. Usually the confidence interval is always 95%. And the range is from 4 feet to 6.6 feet and 5 inch, because yes. So by the confidence interval, you will understand that mostly the data will lie between this range. Most student in your college will have some height between 4 feet to 6.5 inch, right? 6.5 feet. So this is a, basic intuition of confidence interval. But what does actually, how does it actually help in the hypothesis testing? So for this, we will look into the next topic. And another thing to be noted here, that population with lots of variation leads to varied samples with high variation, and which leads to higher confidence interval. I mean, suppose you have a tree in your garden, and mostly the that is apple tree, and most apple are red. Suppose this is the apple. Most apple are red, and there are also some green apple. Now, to find the number of green apple or the red apple, you can set a confidence interval that, suppose we are talking about the green apple, the number of the green apple in your garden. So suppose your confidence interval is 30 to 50, which denotes if you find a apple that is most likely to be green, and the number of it will be something ranges between 30 to 50. If you suppose you do a test, and the test is you have to find the maximum number of green apple in that garden. So by the definition, the unknown parameter is what? The maximum number of apple. So in this case, the maximum number will be something between 30 to 50. It denotes this. Now moving to the next thing, hypothesis testing. All right. So what is hypothesis testing? In easy words, it is a claim that we want to test. Suppose we give a statement. Now we don't know it is right or wrong. So we try to investigate to find out whether our test state is correct or wrong. So what is hypothesis testing? Basically, it is a claim. It is a claim that we want to test. Now let's talk about some examples, whether it will be a hypothesis test or not. Before that, let's talk about some fundamentals of hypothesis testing. There are two types of hypothesis tests. One is null hypothesis, and another one is alternative hypothesis. Okay. And alternative hypothesis. All right. So by the term null, what do we understand? Zero or empty, right? Most of you understand zero or empty. By the term null hypothesis, we try to say that the statement is false or false faulty hypothesis. So we can think it as a false hypothesis. And alternative hypothesis is everything that is not a null hypothesis. So let me make it clear for you. The null hypothesis is something that is currently accepted for all. So the null hypothesis is currently accepted for all. Suppose there is a research that 50% of users use 75% of the users in USA use iPhone. So this is a null hypothesis, right? We want to prove that now not 70%, maybe some higher values, maybe 80% or 85% of USA citizens use iPhone. So in that case, the alternative hypothesis will be that statement. So what was proven or what was tested before, that the 70% people uses iPhone in USA. So that is null hypothesis, and we want to prove that no, 70% of people does not use iPhone in USA. So that would be our alternative hypothesis. So our main motto or goal would be to reject the null hypothesis. We want to reject the null hypothesis. This is be our main target as a statistician. Reject the null hypothesis. I think the screen is very laggy. Guys, can you see the board clearly, or you can also feel the lag? Okay, I might switch to another page. Just a second, please. All right. We were talking about the null hypothesis and alternative hypothesis. So let's write it again. Null hypothesis and alternative hypothesis. We denote the null hypothesis as H0, as the null denotes zero or empty. So we denote it as H0, and the alternative hypothesis is denoted by HA or H1. And just like we were saying that in null hypothesis, we usually in hypothesis testing, we usually try to reject the null hypothesis, and the null hypothesis is something that is previously researched or previously stated, and our alternative hypothesis is what we are trying to prove. So let's see few examples. Let's say, firstly let's see if one statement is worth of hypothesis testing or not. Suppose your statement is apple in New York City is expensive. But can you say that it is a statement or that we can work with hypothesis testing? No, because it is now an idea or statement. But if we associate a value with it or we compare it with something, then we can use it for hypothesis testing. Such as, let's say, the apple in New York City is higher than $1.7 per pound, 1.7 per pound. So if we associate a value with it, then we can say that yes, we can do hypothesis testing with it. Then let's move to another example. Let's say uh, we say users are buying MacBook Air M1 more. The the shade gold, the shade gold are more popular in users. Can we say that it is a statement or it is worth hypothesis testing? This is not this is not worthy of testing, right? Because it is a statement right now. There is no proof or there is no data that it is more popular. We have to compare it with something. So if we say that the cell of gold color is more than the space gray, then it is a hypothesis. So if we say the cell of gold color of your M1 is more than space gray, then it is a hypothesis. So in this case, what will be the null hypothesis and what will be the alternative hypothesis? The null hypothesis would be the cell of gold is more, exactly this sentence. The cell of gold color of air M1 is more than space gray, and the alternative hypothesis would be the cell of gold color of your M1 is not more than space gray. So basically, the alternative hypothesis is everything that is not a null hypothesis. Then let's say another example. We we have something like this, that USA would do better under Clinton administration or Trump administration. Can you say that it is a statement or hypothesis? Like, is it a casual statement or it is worth hypothesis testing that US would do better under Clinton administration or Trump? Can you say that is it a statement or we can do hypothesis testing with it? Yes, this is a casual statement. You know why? Because we have no data for this part. We have never seen Clinton. We have never seen Clinton as the president, right? So another statement, if here was Obama, that would be a hypothesis because there is data. So we have to have data to something to compare with. Like in this case, there was no data for Clinton. but in the Obama part, we had some data, so it is worth hypothesis testing. So there are 4 steps. Now we are going to talk about how to do hypothesis testing. There are 4 steps of data-driven decision making. So to conclude something, you should have data. 4 steps of data-driven decision making. One is formulate hypothesis. You have to formulate the correct hypothesis. Such in this case, we see there were many statements. There was a lot of statement that was not a hypothesis. Formulate a hypothesis. Then we have to find the right test. There are different kind of tests such as Z-test, T-test, ANOVA test, then chi-square test. So we have to find the correct test for our hypothesis testing. Then we have to execute the test. And then we can make a decision. All right. So there is a website named Glassdoor, and from that website we have this information that the mean salary of a data scientist in USA is $113,000. So this is a data that the mean salary of a data scientist in USA is $113,000. So in this case, what would be the hypothesis, a null hypothesis and alternative hypothesis? The null hypothesis would be the mean is $113,000 and the alternative hypothesis would be that the mean is not, the average salary is not $113,000, right? So we can say that the null hypothesis is true until rejected, similar as innocent until proven guilty. So until the null hypothesis is rejected, we can say it is true, such as innocent until proven guilty. Now, your friend, suppose any of your friend, tells that the mean salary of the data scientist is more than this value, right? Uh, so in that case, what would be the null hypothesis and alternative hypothesis? The statement is that the mean salary is more than $113,000. So in this case, what would be the null hypothesis and alternative hypothesis? So in this case, the null hypothesis is the mean salary would be greater. Exactly this statement, the mean salary is more than $113,000, and the alternative hypothesis would be it is less than this value. So just like I said, that anything that is not a null hypothesis would be alternative hypothesis. So it is less than 13,000 $113,000. So the outcome of the hypothesis test refers to the population parameter rather than the sample statistics, right? So we will get the idea of the population, not the sample, though we are using the sample. Now let's talk about significance level known as alpha. So what is the significance level? The significance level or value. It is in probability, in statistics, the significance level is known as the probability of rejecting the null hypothesis. So in simple word, it is the probability. This is the probability of rejecting the null hypothesis. And usually the values for alpha are typically 0.01, 0.05, 0.1. Typically we will see that this value is mostly used. Now let's have some examples to understand this topic more clearly. Suppose there is a candy making machine and you want to test that if the machine is working fine or not. So you expect that machine to work well, right? So in this case, you pick a very low significance level. In this case, suppose you pick 0.01 as your significance level, I mean alpha. Why is that? Because machines usually make less mistakes than human beings. So there are very less chances of making mistakes since this is a machine. But suppose you're analyzing a human or some company's statistics, then you'd be more drawn towards 0.05 as your significance value because usually humans can produce uncertain behaviors. So in that case, the uncertainty or the probability of rejecting the null hypothesis would be more. So in the in that case, your null hypothesis would be more if your statement is associated with human or companies. Okay, so suppose your class teacher told that most of the students got 70% in their stat exam. So let me write the example that class teacher told that most of the students got 70% in their stat exam. But you're not really convinced with this. So you want to do a hypothesis test in this. So in that case, your population mean is 70%, population mean grade. So your null hypothesis would be something like that yes, most of the student got 70% in their stat exam. So the population mean would be 70%. But in your alternative hypothesis, the population mean won't be 70%. It will be something higher or something lower. And to find that, you will do Z test. Or yes, there are some other tests as well, but let's talk about Z test. And the formula is population mean minus hypothesis mean by standard error. So in this case, this is your sample mean. And you know what? What is the sample in this case? You would pick some students and you will see if they got more than 70 or not. So some students in your classroom who gave statistic exam would be your sample, and the population will all of the students who participated the exam. But you know, this is a very small case, so that's why the population is very small. But in real life, the population would be very big. Just like in this case, some students who gave this exam, right? The mu is the hypothesis mean, hypothesized mean, and this part is your standard error. So suppose these two values are same. You get exactly the same value as sample mean as your hypothesized mean. So your z-test will be 0 if these values are similar. So in that case, you will accept the null hypothesis. So if your value is 0 or near to 0, you would accept the null hypothesis. But there will be cases where you don't accept the null hypothesis, you reject the null hypothesis, and that is your main goal. So, how big your z should be to reject the null hypothesis? How big your z should be to reject the null hypothesis? So, now we introduce the cutoff line, or also known as decision boundary. Your cutoff line would determine whether you will accept the hypothesis or you will reject the null hypothesis. Cutoff line. Suppose this is your distribution and this is your mean, and your significance value is 0.05 as we were working with humans, and and this is a two-tailed test. Okay, I will come to this part, that when it will be a two-tailed test, when will it be a one-tailed test. Just before that, bear with me guys, this is a two-tailed test. Simply, what does two-tailed test mean? We will have two part of rejection area, but in one tail test you will have only one tail that will be your rejection area, either this side or this side. So suppose your significance value is this, and since this is a two tail test, as your null hypothesis is that the average value is 70%, and your alternative value is average value is not 70%, so it can be less than 70% or it can be more than 70%. So for this reason, this is a two-tailed test. So in this part we have to divide our significance value with 2, which will give 0.025, and this is your accepting area. and this part together, it will be 0.025, and this part also we have 0.025. Together it will be the whole, which is 0.5. So if we have our value after the z test, which we will do, we will see some examples, is somewhere between this part. It will be then we will accept our null hypothesis. But if your value is somewhere between this part or this part, then you will reject the null hypothesis, right? So suppose after standardizing and getting the value from z table, you find your value as 1.96 and minus 1.96. Then you will do the rest of the work. We will get into this in details, but before that, just have this idea. So I was talking about one-tailed test and two-tailed test, right? So this is an example of two-tailed test. Now we will see where we can use one-tailed test. Suppose your statement is something like, let's go back to the data scientist salary example, which your friend gave, that which was the average salary of a data scientist is $113,000. Now let's modify it. The average salary of the data scientist is more than $113,000. So in this case, you see your distribution will look something different. Your distribution will look the same, but the rejection area will look something different. So suppose this is your distribution. This should be symmetrical, but bear with it, guys. Since the null hypothesis in this case is greater than $113,000, the average salary, and your alternative hypothesis is less than $113,000. So in this case, the rejection area will be something different, because you will reject the null hypothesis when it follows this condition, right? So suppose in this part, the left side of your distribution will be the rejection area, and anything that is not under the rejection area will, we can say that your null hypothesis is correct when it is in this area. When after z we will find the value, if it is in this area, we will accept the null hypothesis. This is one tail test. When your rejection area is on the left, but your rejection area can also be on the right. So suppose the same thing if okay, let's talk about a different example, the example that we talked about previously, the grade example, students who got more than 70% grade. Your In this case, the statement is something like that: most students got grade under 70%. So your null hypothesis would be average value is under 70%, and your this is your null hypothesis, and your alternative hypothesis would be average value of the grade is above 70%, and for that the distribution would look something like this, and this is the part that we are concerned of, that if it is more than 70%. So if the students got more than 70% on average, we will reject the null hypothesis, and otherwise we will accept the null hypothesis. So in the okay guys, do you have any confusion till this topic? If not, I will move forward. All right. So while making this hypothesis testing, we can find some error, and now we will talk about that. And these error are known as type 1 error and type 2 error. So let's talk about type 1 and type 2 error. Type 1 error and type 2 error. Because sometimes your hypothesis testing can be wrong, right? Suppose you take your decision and your result will be something under this four situation. Suppose your result is like result 1, where you reject the null hypothesis when in reality it's false. So you're making the right thing, right? You're rejecting the null hypothesis when it's false. So there is no error, because we know that the we want to reject the null hypothesis. This is our goal as a statistician or as a data scientist. We want to reject the null hypothesis, and we are rejecting the null hypothesis when it's false. So we are doing the right thing. So there is no problem. But suppose there might be another case where you reject the null hypothesis when in reality it is true. When in reality it's true. So in this case, you are making a error which is known as type 1 error. And this type of case is also known as false positive. Okay, false positive. This type of error. Then there might be another case where you accept the null hypothesis when in reality it's false. So this is a problem, right? Because you're accepting the null hypothesis, but it is not the correct thing. It is false in reality. So you make type 2 error. This type of error is known as type 2 error. And there might be another case, that is you accept the null hypothesis when in reality it's true. So you're doing the correct thing. Your null hypothesis is true and you're accepting it. So no error in this case, right? And okay, this type of error is also known as true negative. We will see a confusion matrix for this. Alright, so mostly this type of error, the type 2 error, in this case The type 2 errors probability of type 2 error is known as beta, and normally this type of error occurs when you have problem with the sample size or variance. And this type of error, which is a false positive or type 1 error, usually this error happens when you are making the wrong significance value. You are putting the wrong significance value. We talked about the significance value, right? That when we have to use different kind of that was in different slide. But we talked about the significance value. We have to use different significance value depending on the situation. Suppose you take your significance value as 0.01 and you expect that in this case your null that in this case your let's take the example as the what can I say, the machine is working perfectly, so there will be less error. So you take your significance value as 0.01, that there won't be many chance to reject the null hypothesis. But in the scenario of, suppose, the student's grade case, you can't take this as the significance value. You have to take a higher significance value, because in that case the behavior of humans are pretty uncertain and people can go wrong. So your false positive error is the reason you choosing the wrong significance value. So it is wholly dependent on you. But this type of error are usually caused when you have problem with sample size or variance and so on. So just let's quickly see it in a table, confusion matrix. We will talk about the confusion matrix when we do our machine learning sessions. There will We will talk about this, but shortly let me introduce you to this. We are talking about these things in more organized way in this part, right? So your null hypothesis is true. Your null hypothesis is false in reality. And after completing the test, you whether accept it or reject it, right? So when does your type 1 error cause? When your null hypothesis is true, but you're rejecting it. So in this case, your type 1 error cause, when you will get another error which is known as type 2 error, when your null hypothesis is false, but you accept it. So in that case, that is type 2 error. And the rest of the part is okay, because yes, we are making the right decision, and in this case we are also making the right decision. And this error is known as, like I said, this error is known as true negative. Just a second, please. Okay, this is known as false positive and this is known as true negative. So yeah, this was it. Now we can look at some examples, but we are quite end of the time. The session may include any time. Just a second, please. Okay, guys, we will talk about the Z test in the next session because we are quite end of the time. But if you have any problem till now, you can ask me. I will answer your questions. If you have any confusion, please let me know. We will talk about the Z test in the next session because we are quite end of the time. So do you have any question, please?